Okay, good day everyone. Please stand. Miss Arevalo, kindly lead the prayer.
The Father, the Son, the Holy Spirit. Amen. Our Father in heaven, holy be your name. Your kingdom come, your will be done on earth as in heaven. Give us today our daily bread and forgive us our sins as we forgive those who sin against us. Do not bring us to test, but deliver us from evil. Spirit. Amen.
Okay, thank you very much, Miss Arevalo. Class, please remain standing, and before you take your seat, kindly arrange your chairs properly and pick up the pieces of paper that you can see on the floor. And also, don't forget to put your devices on our box that I provided before, so that you will not be distracted with your phones during our discussion. All right, you may now take your seat. And for our attendance, let me call the secretary of this class. Do we have any absentees for today?
We don't have any absentees po, sir.
Thank you, Miss Bautista. Alright, so yesterday, remember that I gave you an assignment, and today is its submission date. So for your assignment, kindly collect your papers. Miss De Leon, kindly collect their papers and put it on my table at the side. Thank you, Miss De Leon. Alright, so yesterday, we have discussed about the particle nature of matter. Anyone can recall about their understanding about matter? Anyone? Mr. Mooney, do you have any idea about our discussion yesterday?
Sir, we have three states of matter, the solid, liquid, and gas.
Alright, it's good to know that you can still recall our discussion that we had yesterday. So, for today's discussion, we will talk about the atomic structure. Alright? So, for our learning objectives posted here on the board, may I call Ms. Escueta to read our learning objectives?
At the end of the lesson, the student should be able to differentiate between three subatomic particles, explain theories and models related to atomic structure and three subatomic particles, develop mastery in identifying numbers of protons, neutrons, and electrons present in an atom.
Okay, thank you so much, Ms. Escueta. Now, let me ask you, before we proceed to our main discussion, what comes into your mind when you hear the word atom? Anyone? Miss Bautista? Any idea when you hear the word atom?
Sir, atomic structure. Atomic
Yes, it
structure
should be
is
atomic
the
structure.
structure of an atom comprising a nucleus, protons, neutrons, and electrons po.
Okay, any other idea, Miss Castillo? Any idea about atom?
So, atoms po ay cells.
It could be a cell because cell comprises the human body, and human body composes of molecules that compose of atoms, so it could still be connected with cells, right? Okay, so let's proceed to our pre-activity. So the class will be divided into two groups, and we'll do a collaborative word cloud using any online platforms that you can use to accomplish this activity. So what you are going to do is to create a word cloud that relates to atoms, and you have to send it to me via messenger. Alright? So you may now proceed to your group, and I already gave you your the list of the group members. So you may now proceed. Okay, this will be the area for group 1, and this will be the area for group 2. Okay, so I already received your output on my messenger account. So let me present your group's work, alright? Okay, so here is the work of group 1. So, can I call any representative from group 1 to elaborate their output and tell me what it means? How do you come up with these words related to atoms? Can I call for group 1? Let's have Miss De Leon. Any idea how will you come up with these words related to atom? How are you going to relate these words in atom? Yes, please go here in the front.
Okay, the has electrons, protons,
Okay.
some atomic structures, okay, the number, and that's awesome.
Okay, so I got the idea of Miss De Leon's group. So we have here they have here listed the words related to atoms. So we have here atomic and structure. So that composes the idea of atomic structure. There's also words like electrons, subatomic particles, atoms, structures, theories, and models. Alright, so from that we could have the idea about atoms. Thank you so much, group 1. Next. Okay, so they just listed few words. Alright, let's call on group 2. We have Ms. Arevalo. Yes, please go here in the front and defend your work.
Sino nga nag-ano ng ano to? Kay Jed Dalton?
Yes, yes.
Ito
It's
na,
ganda.
Jed. Ba't mo din virtually? Okay, so
Okay.
based on our word cloud, we have atomic theory that's proposed by John Dalton, and Bohr's theories, and we have atomic model which proposed by Rutherford. And we all know that protons, it is a positive charge, and the electrons is a negative charge, and the zero is the neutral. That's all po.
Okay, thank you so much, group 1 and group 2. It seems like you already have your prior knowledge about atomic structure and atoms, including the 3 subatomic particles. But we will go on discussing it further throughout this presentation. Okay, so today we are going to talk about the atomic structure. So, when we say the word atoms, it is the basic building blocks of matter. It is also a particle of matter that chemically defines a chemical element. So, it consists of central nucleus surrounded by a negatively charged particles. Alright, since elementary and in your early years in high school, you have tackled about atoms. And are you familiar with the character Jimmy Neutron?
Yes.
Yes, diba? They use as there the logo of atoms, which is surrounded by orbits where, which electrons were flowing. So we have here the nucleus, which is the compact of the neutrons and the protons, and there are orbits that surrounds the nucleus, and we could see the electrons on those orbits. Okay, so atoms, it is derived from the Greek word atomio, which means indivisible or uncuttable. So that I think that is this is accordance to the theory of John Dalton, which he states that in law of conservation of mass, there is a theory that we cannot destruct an atom, that we cannot destroy it and divide it into pieces. Alright, this compound of atoms makes up the molecules. Just like what I said earlier, that molecules makes up the human body, and molecules composes of atoms. Therefore, atoms are also a building block of the human body. It is a building block of every matter. Alright? So, we are now going to proceed with atomic theories. We have here Dalton's atomic theory, and the model that he created is the billiard ball model of atom. We also have J.J. Thomson's theory, the plum pudding model, Rutherford's hypothesis, which proposes the nuclear model of an atom. We also have here Erwin Schrödinger's model, which proposed the electron cloud model or the quantum mechanics model of an atom. We also have here, last, the wave mechanical model. Alright? Let's proceed with Dalton's atomic theory. It is proposed by John Dalton, who explains the law of conservation of mass. Since when we were grade 7, we have discussed about the law of conservation of mass, and it states that the total mass of an object is equal to the total mass of each parts. So it means that the collection of an object's components mass is equivalent to the total mass of an object. And we could relate it to atoms, since it is stated that atoms were indivisible or uncountable. Alright, so here is the illustration on Dalton's atomic theory. So we have here one oxygen atom at 16 mass units plus 2 hydrogen atoms at 1 mass units is equivalent to 18 mass units, or 1 water molecule at 18 mass units each. Since water molecule, it composes of 2 hydrogen atoms and 1 oxygen atom. And since 1 oxygen atom has a total mass of 16 and 2 hydrogens has the mass of 2 mass units. So we could have 18 mass units for the H2O or water. So let's proceed with J.J. Thomson's theory or model. Please read Miss Evangelista.
J.J. Thomson's theory or model proposed a plum pudding model in 1898. Explains that an atom possesses a spherical shape in which the positive charge is uniformly distributed.
Alright, so you're familiar with pudding, right? It's a type of food. So it is called plum pudding model because it looks like it. His model proposed by J.J. Thomson's, the theory of J.J. Thomson's is almost the same with the features of a pudding. So it explains that an atom possesses a spherical shape. Spherical, which means circular. Spherical or circular or circle. Very good. So the charge is uniformly distributed as stated on this theory. We also have here the illustration of plum pudding model. So we can see here that it is circular and there are negative charges on the sea of positive charges or protons. So there are protons everywhere, and it is also composing of negative charges or the electrons near the positive charge. Okay, we also have here the Rutherford's hypothesis. So this is a theory of Ernest Rutherford. It proposes the nuclear model. When we say nuclear, it something related to nucleus. So he is the proponent who assumed and claimed that the atoms composed of nucleus, which is a compact of the protons and neutrons. So Rutherford and his students bombarded a very thin foil with the particles. So Rutherford's famous particle or a particle scattering experiment. So here is the illustration for Rutherford's model of an atom. So this is the nucleus that he is claiming that it is a part of an atom. Alright, so we have here the illustration of Rutherford's model of an atom. So we have here the nucleus, which Rutherford claims that it is the main or central part of an atom. So this nucleus composes of protons and neutrons that are positively charged and neutral charge or zero, which is yung neutrons. And we have here the electron orbits wherein electrons are located. Alright, let's proceed with the next model. We have here the Bohr's theory proposed by Niels Bohr and proposes the planetary model and explains his theory through working on a dual character of electromagnetic radiation. So this planetary model can be illustrated as this one. So just like the solar system, we have here the orbits. Say for example, this is the nucleus, which
Nandito po siya, tignaw ni Madam Leia.
Ano po yan?
Nandito po na siya.
Ang susi po.
So the planetary model could be illustrated as this one. So we are aware of the solar system, right? And there is the sun wherein the planets revolves around it on their own orbits. So it is the same with the model or the planetary model of an atom proposed by Niels Bohr. So we could see here the central part of an atom, which is the nucleus. So I guess their theories were interconnected with one another. They were like basing each other's theories on their previous works. So we have here the nucleus, and there are orbits, electron orbits around it, wherein electrons are located. Okay? Understood?
Yes, sir.
What are the theories that relates to atom? We have here the Dalton's atomic theory, the Rutherford's atomic model. We have here Bohr's theory. And the last thing that we discussed about a while ago, the nuclear model. Next is Erwin Schrödinger's model. It proposes the electron cloud model or quantum model where negative electrons circle the positive nucleus at fixed distances from the nucleus. So it is almost the same with the other atomic theories, since it also composed of the three components of an atom, which are the nucleus composing the protons and neutrons, and we also have there the electrons that surrounds the nucleus at a fixed distance. It also emphasized that the distance of the electrons from the nucleus is fixed. So this theory also stated that electrons travel in waves, which makes their positions undetermined. So we cannot literally measure the distance between the electrons to the nucleus because they travel in waves. If we look on an orbit pan, say we look in an orbit pan and you turn it on, diba we have here the individual parts or the three individual pans of an electric fan, and if it's off, we can see the three individual parts. But if it runs, we cannot see it. That makes it look like a cloud. So we cannot identify which one is at the same time. And also, we could relate it to atom because there are electrons that you cannot identify because it moves so fast. So it travels in waves, which makes its position undetermined at a given period of time. Alright, let's proceed with the illustration of this model. So we have here the electron cloud, the blue one. You can see it clearly at the back.
Yes, sir.
Alright, thank you. So we have here the nucleus at the central part of an atom. We have here the electron cloud where the electrons are located. Next. We have here the wave mechanical model, which is proposed that the electrons act like particles as well as waves of energy. So from the word itself, wave mechanical, this is how waves move, and we could relate it to atoms. So this theory relates, or this model relates the atomic structure, and atomic molecules on waves energy or waves of energy. So this could be illustrated using this graphics or image. So we can see here waves that surrounds the central part of an atom, which is the nucleus. So we could see the electrons located here on this part. So this is the theory based on the wave mechanical model. Now, since we discussed about the different atomic theories and models, we are going to perform an activity called Fit Me Right. So, you will be assigning words to different theories that I'll be posting here on the board. So, I'll be giving you some words that you can assign to each models. So, I'll be putting here. Let's move the learning objectives on this part of the course. Okay, everyone. So I'll be calling few students and I'll be giving you words or phrases and you're going to assign these words to the corresponding atomic theories if you think it belongs. Alright, minimize your voice, everyone. Okay. Miss Arevalo, can you assign this word? We have here nuclear model. Which do you think it belongs? Let's call Miss Escueta. I have here foil experiment. Which do you think this phrase belongs? Okay, another Miss Castillo. Miss Bautista. Let's call here Miss De Gracia. Okay, take your time. You still have time for you to finish the activity. Mr. Revelo. At fixed distance. Alright. Again, Miss Castillo. Yes, at fixed distance. Again, Escueta. Okay, thank you. Why do you think it belongs here? to the plum pudding theory. What can you recall about plum pudding model which relates to J.J. Thomson's theory? Who answered this one? Mrs. Queta, how do you think plum pudding model relates to or assigned or aligned with the J.J. Thomson's theory?
Kasi po, yung structure niya is like, is like pudding.
Okay, thank you so much, Miss Escueta. Let's call Miss Arevalo. Which one of these atomic theories did you put your words into?
Ano po? Fixed distance kay Erwin Schrödinger model.
Okay. Okay. How do you say that fixed distance is aligned or unfold with Erwin's Schrödinger model of atom?
Because in Erwin Schrödinger model, it has axis or orbital that they are yung atom is nagta-travel through their orbital. So we can say that there's a fixed distance because they have the same distance between the orbits.
Okay, good idea, Miss Arevalo. And we have here Rutherford's hypothesis, which is nuclear model, so correct. We also have electrons surround the nucleus. We also have for Bohr's model, the planetary model. So this is correct. This is what the solar system looks like. That's why it is called the planetary model. We also have here Dalton's atomic theory. So it explains the atomic structure through the use of the law of conservation of mass and the law of multiple proportions. And the next, we have here Erwin's Schrödinger model, which is explained by Ms. Arevalo. We have here the wave mechanical model, radiation. Okay, this could be connected with wave mechanical model still. J.J. Thomson's theory, which have the plum pudding model. Alright, so this is all correct. So it seems like you already grasped the ideas about different atomic theories and models. So we will be proceeding with the three subatomic particles. So we have here the protons, neutrons, and electrons. Who have any idea or who can recall what protons, neutrons, and electrons means? Miss Bautista, please, how can you differentiate, or what do you think are the differences between protons, neutrons, and electrons?
Protons are atomic particles which has positive charge, while electrons are atomic particles with negative charge, and neutrons, they don't have charges.
Okay, so protons, based on the learnings that you had on your previous years, protons were positively charged, neutrons, which is neutral or zero charge. We also have here electrons, which is negatively charged. Okay. So protons, can you read, Miss De Gracia? What is protons?
Protons, a stable subatomic particles, symbol P with a positive charge of positive E, positive 1 E. Its mass is slightly less than that of a neutron and 1,826 times the mass of an electron. Protons and neutrons, each with masses of approximately 1 atomic mass unit, are jointly referred to nucleons.
Okay, so I will not be explaining this further anymore because you already have the knowledge about protons. So this is another subatomic particle which is joining the neutrons, forming the nucleus, and collectively the neutrons and protons is called as nucleons. All right, so this is subatomic particles with P symbol and the charge of positive 1e. So we also have here neutrons. Please read Miss Maria.
Neutrons, atoms of all elements except for most atoms of hydrogen, have neutrons in their nucleus. Unlike protons and electrons, which are electrically charged, neutrons have no charge. Its mass is slightly greater than a proton, which is 1
AMU. Okay,
AMU.
1 AMU. Alright, thank you so much, Miss Nemaria. Neutrons, it joins the protons to form a nucleus, which they were referred collectively as nucleons, as I said earlier. So this is almost the same in mass with protons. The difference is just, it is slightly greater within that of protons because it is less than the 1 atomic mass per unit. So, we also have here electrons. Please read, Miss Castillo.
Electrons. Unlike protons and neutrons, which consist of smaller, simpler particles, electrons are fundamental particles that do not consist of smaller particles. They are a type of fundamental particles called leptons. It has negative charge.
Okay, thank you so much, Miss Castillo. So, electrons, unlike protons and neutrons, it consists of smaller and simpler particles. So, electrons are fundamental particles that are composed of fundamental particles that consist of smaller particles. So, they are a type of fundamental particles that called leptons. So, it has a negative charge. Alright? So, we are going to proceed on calculating number of protons and neutrons as well as electrons. So I'll be removing it first because I'll be showing you or demonstrating you how the calculation of protons, neutrons, and electrons is being done. So let's suppose, okay, the first thing you need here is the modern periodic table. So, it's very important that you have the latest model of this periodic table. So, to ensure that this is the current model, you have to check if the last element is organison or with the symbol OG. Okay, so the first thing you need is the modern periodic table, and then aside from that, you'll be needing a calculator to solve sort of calculations here in the number of protons, neutrons, and electrons. Okay, so to calculate the number of subatomic particles present in an atom, use its atomic number and mass number. So let's use the element nitrogen here. So what is the atomic number of nitrogen?
7.
Very good, 7. So its atomic number or atomic number is 7. And to calculate the number of protons, we have to remember that the number of protons is always equivalent or equal to its atomic number. So if the atomic number of nitrogen is 7, what is its number of protons or what are the number of protons present on it?
7.
Okay, very good. So the protons present in nitrogen is 7. For the number of electrons present in the nitrogen atom, we have to use this formula. Electrons is equal to protons minus its charge. Okay, so if our element here, nitrogen, have 7 number of protons, we will be deducting it with a charge of nitrogen. So let's suppose that the number of charge present on nitrogen is, let's check it, negative 1. So let's suppose that the charge here is negative 1. So we will be putting it here, negative 1. Alright. Since it has similar sign here, this will be
Positive.
positive. Okay. So for the number of electrons, 7 plus 1, since it became positive, 7 plus 1 is 8. So the number of electrons present on nitrogen is 8.
8.
Okay. Lastly, for the last subatomic particle, we have here the formula for the calculation of neutrons. So it says here that neutrons is equal to the mass number of an atom minus its atomic number. So the mass number of nitrogen
14.
is
14.
14. Alright, very good. So we have 14, which is the mass number of nitrogen, and minus its atomic number, which is 7. Therefore, the number of neutrons present on the nitrogen is 7. Alright. Who can recall the process of solving or calculating the number of protons, neutrons, and electrons of an atom? Let's call Miss Bautista.
First, we need to know what is the atomic number of the element. So, the atomic number of nitrogen is 7. And to know the protons, since the formula for protons is that protons is equals to atomic number, so the protons of nitrogen would be 7.
Okay, 7.
For electrons, we need to find the charge of the nitrogen and subtract it from the atomic number of the nitrogen. So, the atomic number of nitrogen is 7, while we assume that nitrogen has -1 charge. So, if we put it in an equation, 7 minus the quantity of -1, both the negative will be positive and then the charge will be positive, or it will be an addition. So, 7 plus 1 is equals to 8. So, the electron of nitrogen is 8. While, lastly, for the neutrons, we have to know the atomic mass of nitrogen. The atomic mass of nitrogen is 14, and then minus it or subtract it rather with the atomic number, which is 7. We will have the neutrons of nitrogen as 7.
Okay, thank you so much, Miss Bautista. Very good. It's good that you can understand well how we are going to calculate the number of protons, neutrons, and electrons present in an atom. So again, let me summarize it for you. To calculate the number of protons, let's suppose that we are going to use nitrogen, and the atomic number of nitrogen is 7. Therefore, the number of protons on nitrogen is 7 because it is always equivalent to the number of, or to its atomic number. Next, we have here electrons, and to calculate it, we have to know the atomic number of an element and deduct it with its charge. So let's suppose that nitrogen, which has the atomic number of 7, has a charge of -1. So we are going to put -1 on the equation. And since it is both negative, its sign would be positive. So this will be addition. So 7 plus 1 is 8. And to calculate the number of neutrons, we have here the atomic mass minus its atomic number. So the atomic mass of nitrogen is 14, and the atomic number of nitrogen is 7. So if we deduct it from one another, we would have the number of neutrons, which is 7. So that's it for the calculation of the 3 subatomic particles. So for the next activity, you'll be using an online collaborative whiteboard. So the learners will use any online platform that they can use in order to accomplish the task. So I'll be sending, I'm sending a link for you to access so that you could solve through the online whiteboard. So I already posted the link on our Google Classroom, so you just have to check it out. Work on your own devices. I'll give you 15 minutes to finish the activity. So that activity will be a computation on the number of protons, neutrons, and electrons present in an atom. So the questions will be posted here at our monitor. So we have here the practice problems on subatomic particles. Number 1, let me read this for you first. An element nitrogen have the atomic mass of 14 and 7 number of electrons. Find the number of protons present in nitrogen. For number 2, please read Ms. Bautista.
Nitrogen have the atomic mass of 14 and 7 number of electrons. Find the number of neutrons present in nitrogen.
Okay, number 3, Mr. Muni.
A cation magnesium has a charge of 2 positive. Give its charge. What is its number of electrons?
Miss Arevalo.
A cation magnesium.
Okay, we are going to number 4.
An ion carbon 4 has blank number of electrons.
And an ion carbon 4 negative has blank number of electrons. Last, find the number of neutrons present in phosphorus. So you will be working on it in an online whiteboard for 15 minutes. So each of these items have to be solved in 3 minutes time frame. So your timer starts now. So the link is already posted on our Google Classroom. You just have to access it. So work on your own devices. Alright, that concludes our discussion for today, but today's activity doesn't end there. So we will still have an assessment. So please read the direction, Mrs. Weta.
To evaluate your learning and understanding about the topic discussed, answer the prepared assessment in Google Forms, which will be answered in 15 minutes. Link on quiz is available in your group chat.
Yes. So the link is already posted in our Google Classroom, and I also send a link in our group chat on Messenger. So you have to access it, and you have 15 minutes to finish the assessment. So let's start your quiz right now. Again, focus on your devices. No chit chats and avoid cheating. Strictly, cheating is not allowed. Okay guys, last 10 seconds. Okay, let's go for it. There are still answers that I am receiving right now. Okay, you still have time. Last 5 seconds. Okay, is everybody done? Okay, thank you. Yeah, I already received all of your answers here, including your emails. Okay, so the result of your quiz will be posted on our Google Classroom again, and it will also be announced, don't worry. It will also be announced in our group chat on Messenger. So, your assessment is already done, but we have an extension activity. So you will have an assignment. For the direction, please read Miss Nimaria.
Create an atomic model with complete labels and components. The assignment will be passed next week and will be graded using the criteria below. So for the criteria, craftsmanship 10, visual appeal 15, completeness of details 15, timeliness is 10, and with a total score of 50 points.
Okay, thank you so much, Miss Nimaria. Now, this activity, I forgot to post it here, that this will be a group activity. So the list of group members will be sent on our group chat, and you have the weekends to work on your model, and that will be passed on our next meeting next week. Alright, so please all stand. Okay, please all stand. Okay. Again, thank you so much everybody for cooperating, and see you around.
Thank
Thank you, sir, for teaching us.